not all functions have an inverse. Okay, so for example, if I have a function that looks like this, which is your standard parabola, okay, if this was f of x, I know for a fact that f inverse of x would be a reflection of it on the line y equals to x. Okay, all the intersection points between any function and its inverse will always happen on the line y equals to x. These intersection points that always happen on the line y equals to x. Okay. In another word, if f of x crosses y equals to x, then there will be a point of intersection. All right. Okay. Now, as soon as that is done, I can see that f inverse of x. This in this particular case, if I draw a vertical line, yeah, it's going to cross at 2 points. That means f inverse of x is not a function because it does not pass. It does not pass the vertical line test. Well, so in that case, how do I figure out if function does actually have inverse? Well, if for this one, for example, if I have, let's redraw this graph. Okay, before it's reflected, the vertical line test is a horizontal line test. Okay, so if you think about what's going on here, f of x, if it does not pass the horizontal line test, then its inverse will not pass the vertical line test because it's a reflection. Yeah, so what the horizontal line test and vertical line test do is this. For a vertical line test, what happens is I know that it tells me if f of x is a function. For horizontal line test, it tells me two things. Okay, the first thing it tells me is what type of function f of x is. Okay, you have two choices. It's either a 1-to-1 function, or it is a many-to-1 function. Okay, in this particular case, it's a many-to-1 function. In another word, the horizontal line test will also give me, okay, it will, whoops, let's go back to here. Okay, it will also tell me if the function, f of x has an inverse. Okay, so the vertical line test tells me one thing, if f of x is a function, done. The horizontal line test tells me two things. One is what type of function it is, and if the function would have an inverse. If it's 1-on-1 function, it will have an inverse. If it's many-to-1 function, it will not have an inverse. Okay, so this two part is closely knitted with whether it has an inverse. Now, from this point onward, we do need to talk about domain restriction because, for example, okay, so let me just show the last part of here using a question. Now, if I say for f of x, I don't know, equals to x squared minus 6x plus 11, for example, for this function, okay, restrict the domain, such that it has an inverse. Well, if you look at parabola, what part would it have inverse? Well, pretty obviously, parabola looking like this. If I actually looking on the right-hand side of a line of symmetry, or if I look on the left-hand side of line of symmetry, both would tell me there is an inverse. Okay, it doesn't really matter which one you choose. You just choose the one that makes sense to you. Normally, we choose the positive side. Okay, so but before that, I need to know what is line of symmetry. So for this particular question, I know line of symmetry happens when x equals negative b over 2a, which happens when negative b is 6 over 2a, which is 3. Okay, so for this one, I know that therefore the domain restriction will be x greater or equals to 3 for all x is a real number. Okay, or if you want to write in interval notation for the other side, let me just demonstrate. You can say that x is between 3 and so negative infinity and 3 inclusive and exclusive. Okay, either one is fine depending on which interval, which notation the question asks you to do, and it's up to you if you want to go to the left hand side or the right hand side.